Welcome to Casting Academy. In previous chapter, we discussed simple formula about the mechanisms, the Kutzback criterion and Grublers criterion, degrees of freedom, etc. In this also continued chapter from that one. Last formula just we recall. In our topic is kinematics of machines, basic mechanisms in these degrees of freedom. First of all, what is degrees of freedom? Number of inputs motions are required to produce motion, constrained motion in a mechanism. Number of inputs required to produce motion. Planar mechanism versus spatial mechanism. Planar versus spatial mechanism. Planar mechanism means a mechanism all the links are lie in same plane, which means every link has x and y translatory motion and z in z direction that have rotary motion. So in planar mechanism, the mechanism have 3 degrees of freedom. As well as in spatial mechanism links are lie in different planes. Various links are lie in different planes. So now we describe the links in different planes. Example, robot arm, crane, hook joints are the example for the spatial mechanism. Here the degrees of freedom is 6. The x and y z translatory motion as well as x and y z rotary motion. So planar motion only 3 degrees of freedom and spatial we have 6 degrees of freedom. So we describe Kutzback equation for degrees of freedom of planar mechanism is degrees of freedom 3 into n minus 1 minus 2p1 minus 1p2. Here the n is number of links, p1 equal to number of pairs with 1 degrees of freedom and number that means lower pairs. P2 means higher 2 degrees of freedom, number of pairs with 2 degrees of freedom, number of higher pairs. Degrees of freedom, that is also into 3 into n minus 1 minus 2l minus h, l equal to lower pair and h equal to higher pair. So next formula, Kutzback criterion for mobility of spatial mechanism. Spatial mechanism. So degrees of freedom into 6 into n minus 1, 5p4, 4p2, 3p3, like this. Grublers criterion for planar mechanism. This is only applied only single degree of freedom or overall mobility is unity. Substitute h equal to 0 and n equal to 1 in Kutzback criterion. We will get 3 into n 2 minus 3n minus 2l minus 4 equal to 0 as well as 6n minus 5p1 minus 7 equal to 0 for spatial mechanism. This is for planar mechanism, this is for spatial mechanism. So already we discussed if degrees of freedom equal to 0, device is statically determined structure. If degrees of freedom greater than 1, device is a mechanism with constrained motion. So less than or equal to minus 1 are statically indeterminate structure. So what we discussed in basic mechanism, the degrees of freedom. What is degrees of freedom? Number of inputs required to produce motion. Planar mechanism versus spatial mechanism. So that degrees of freedom also. Kutzback criterion. So Kutzback criterion for mobility of spatial mechanism as well as degrees of freedom and constrained motion. Now we go for problems. Solved problems on degrees of freedom in Kutzback and Grublers equation. Problem number 1. Using Kutzback criterion, find the degrees of freedom. Here, problem A, we have 3 link structure. Number of link equal to n equal to number of links and j equal to number of lower pairs or number of binary join h equal to higher pair. So here we all have n equal to j equal to 3. This means 3 links and 3 binary joins. So we put problem dy of 3 into n minus 1 minus 12 minus h. So dy of equal to 0. So we get structure, no relative motion. Here we got structure. This is called a structure. There is no relative motion between the various input links. Next, this is called 4-bar mechanism. We applied n equal to l equal to j equal to 4 and higher pair. Now there is no higher pair. Higher pair means point of contact. So degrees of freedom equal to 1. So 4-bar chain with a single input motion for this problem. Here the mechanism with the cam and follower. Cam and follower. So here what are all the links? This is roller follower, cam. This is frame. Number 1 is frame. So link equal to number of links equal to 4 and j equal to 3, l equal to j equal to 3, h equal to 1. Where h? Between roller pair and the cam follower we have higher pair, h equal to 1. So here degrees of freedom equal to 2. Here the DOF equal to, so there is 2 separate input motions to used to drive the cam and follower. Here the same case, but the case is knife edge follower. So we put the formula and get only 1. So single input motion we run to this. Next, find the degrees of freedom of mechanisms. Here the number of links equal to 8, binary joint equal to 2 and ternary joint equal to 4. Remember, ternary joint equal to 2 into 2 plus 4, that is equal to 10. So lower pairs l equal to j equal to h, we got 1. So degrees of freedom equal to 1. Single input motion is used to drive the mechanism. The last one, this one is another mechanism. Here number of links equal to 8, binary joint and joints are equal to 9 and h equal to 1 and h equal to lower pairs equal to j equal to 9. So the equation is degrees of freedom. We got two separate input motions. Finally this mechanism, n number of links is equal to 7, j equal to 8, l equal to j equal to 8, h equal to 0. So here we have got 2 separate input motions to run this mechanism. So now we cover only the basic mechanism in first unit of kinematics of machinery. In future we shall cover remaining part. Thank you.